Hello, we are going to talk about recycled tyre materials in construction and in particular on the sustainability of concrete with recycled tyre materials. I'm Alessandro Fantilli from Politecnico di Torino, Italy.
And I'm Tomoya Nishiwaki, Associate Professor of the Tohoku University, Japan.
This is the outline of our presentation. We will talk about concrete, which is a very old material. And here you have an example of the Dome of Pantheon in Rome. It was built about 2000 years ago and was made with concrete. So it is important to know what the concrete is, how popular is concrete, and of course also the environmental impact produced by the production of concrete. Then we talk about the possible sustainable approach to have a more environmental friendly concrete with recycled tyre materials, and then we will draw some conclusions.
So let me explain the concrete using a simple analogy, a cake. Just like baking a cake, concrete constructions needs good recipe. The final result, quality of concrete or the taste of the cake, depend on the several things. For example, the quality and quantity of ingredient, and careful mixing, and appropriate curing or cooking. So the recipe for concrete is just as important as the recipe for the cake. Uneven mixing or improper baking or curing can spoil both the cake and concrete. Both cake and concrete needs a good recipe and careful attention at every step. So let's think about what we need to make cake. Here are the ingredients for a simple mori cake. We use milk, flours, sugars, eggs, and baking powders in the right amounts. Each ingredient play an important role in making cake soft and tasty. Now, this is a recipe for concrete. In 1 cubic meter of concrete, we have cement, water, aggregate, and a small amount of admixtures with a proper amount. Aggregates make up the skeleton of the concrete, and cement, together with water, act as glue that hold everything together. Just like a cake, the final quality of concrete depends on the recipe and the process, how carefully it mixes and cures.
In other words, the preparation of concrete and the preparation of a cake is more or less the same. As you can see, the first step is mixing the components of both concrete and cake. Then we have to transport from the mixing zone to another zone the mixed material. And in particular, in the case of a cake, we have to transport the mixed material in an oven. In the case of concrete, we have to transport the concrete, the mixed concrete, in the place where we are casting the construction and curing it. As a result, concrete is a very popular material, like cakes, because it is very easy to use and it can be used for all the types of constructions, from a small house for a dog or cats, and also for very large infrastructures. We can estimate the production of concrete in 30 billion tons per year, which is the most used manufactured material, the most used in the world after water. But the popularity has a cost, and the environmental impact is the cost for mass production of concrete and cakes. In particular, as we can see in these pictures, the unitary impact of concrete is lower than the unitary impact of a cake. The unitary impact here is defined by the tons of CO2 per tons of materials produced. But in only 1 year, we just produce 30 billion tons of concrete and only 19 million tons of cakes. For this reason, the carbon footprint of concrete is 1,000 times greater than that of the cakes. As a result, the 80% of the world's total CO2 emission is due to the concrete production.
So now let's talk about the super strong concrete. By changing the recipe, the quality and quantity of the raw materials, we can create the concrete with a much higher strength. UHPC, or ultra high performance concrete, can reach more than 150 MPa, about 5 times stronger than the normal concrete. Of course, this type of concrete uses much more cement, so the CO2 emission per unit volume is much higher. On the other hand, since the stronger concrete allow us to use a smaller amount of materials, the total CO2 emission can actually be reduced. So the better strength means not only the stronger structures, but also more sustainable solutions.
The mass production of concrete needs a large use of raw materials, natural materials, and in particular sand and gravel, which are the components of concrete as aggregates, are the most extracted group of materials, even exceeding fossil fuel. And as you can see in these diagrams, the availability of sand is becoming lower than the demand of sand. And we expect in the near future an increment of cost of this aggregate. Therefore, according to the Agenda 2030, and in particular the goal number 12 of this agenda, we have to ensure sustainable consumption and production pattern of the concrete aggregates. To reduce the use of raw materials, we can use recycled materials. In the specific case of concrete, we need to change the recipe by substituting sand and aggregates in general with other materials, such as the rubber from end-of-life tires. Here we have an example of 2 different recipes. In particular, in the recipe number 1, we have the traditional concrete made with cement, water, and sand. In the recipe number 2, cement and water are the same, but sand is partially substituted with the rubber from end-of-life tires. If we analyze the performances of the concretes made with recipe number 1 and recipe number 2, we observe that in the second case, the final results provides a concrete weaker than the concrete obtained with recipe number 1. In the specific case of bending test, we observe that if rubber substitutes some stone sand, the flexural strength of concrete reduces.
So let's look at the fiber reinforcing concrete, or FRC. FRC is a concrete with a reinforcing fiber mixed into the recipe. Normal concrete is brittle, as you can see in the top animation. It suddenly breaks into the two pieces. But FRC behave very differently. It bends instead of the breaking. This ductile behavior allows it to absorb energies, which is especially important in the earthquake-prone countries such as Italy and Japan. By adding the sufficient amount of steel fiber, as shown in the middle photo, we can achieve this strong and flexible performance. This fiber can be recycled from the end-of-life tires, making FRC not only stronger, but also the more sustainable.
We can introduce also a new recipe number 3, which is a fiber reinforced concrete. In addition to cement, water, sand, rubber from end-of-life tires, we have also steel fibers from end-of-life tires. If we test in bending the concrete obtained with recipe number 3, we observe that the strength is the highest, or better, is higher than the concrete obtained with recipe number 1 and recipe number 2. So, with rubber and fibers from recycled tire materials, the performances are the best performance that we can have, and they are better than the performances that we can obtain with concrete obtained with recipe number 1. In other words, if the recycled tire materials are properly used, the final concrete is even better than the concrete of recipe number 1, in which we use only natural materials. What we have seen before has been also applied in the recipes of real structures, and in particular the concrete or the components of concrete in the so-called predals were substituted by recycled materials. As you can see in this picture, predal is generally used for casting the slabs of floors in building constructions. When in these slabs we substitute about 40% by mass of natural materials with recycled materials, including also recycled tire materials, the final performances of the structure does not change. It means that also with a large mass of tire recycled materials, we can have safe and reliable structures. In conclusion, we have concrete in our life and we can see it everywhere. It is the most used manufactured materials, and unfortunately it has also a large impact. To reduce this impact, recycled tire materials can be used by using the rubber, the steel fibers, and also textile fibers from end-of-life tires. We can reduce the natural resources needed to cast concrete. However, in this substitution, if the material are properly used, we can obtain the same results that we have in the concrete made with only natural materials, and real full-scale application of the recipes of concrete with recycled materials are possible. Thank you very much for your attention.